All right. Hello, my name is EJ Daigle, Dean of Robotics and Manufacturing at Dunwoody College. This will be the second video in my Machine Vision 101 series. If you have not watched on YouTube, the first video was Machine Vision 101, your first vision application. You could find this a couple different ways. If you type in Machine Vision 101, Machine Vision Dunwoody, anything like that, you should be fairly quick and easy. Or if you go to youtube.com/Dunwoody Robotics, that's another way to get to it fairly quickly and easily. So what we do at Dunwoody is we work with the Cognex Insight software, and we have a number of the Cognex Insight 7000 series cameras. So in our industrial controls and PLCs lab, we're working with the Cognex with PLCs, Allen Bradley, Siemens, as well as touchscreen HMIs, motor drives, all of the like. But by combining machine vision, that gives us the ability to not only control a process, but actually look at the output of the process and make sure that if we're creating parts or sorting materials or something like that, or analyzing inputs, the machine vision gives us some ability to do that. So what I'm going to do today is we're going to work with the pattern tool a little bit. Specifically, I've got some images for my students that I've set up on the Canvas site. So you students are going to want to work with the fuse images. You can find those on our Canvas course page. For anyone else, you can watch, and it's worth noting that what we're using the software for in this particular example, I'm sitting at my dining room table. I'm not in the lab. And what that means is I'm going to be using an emulator. And if you don't have the software installed, or if you don't have the emulator working, go and watch my first video in the series, and that will describe how to download the software for free, how to set up the emulator, and then you could even take your own pictures of various things and use them for testing purposes. Or if you had a camera, you obviously could hook up to a camera and do this live. So first step would be get connected. Normally, if I get connected, I'm going to have a choice of my emulator or a camera that I might be networked currently to. Because I'm not networked, we're only going to be able to work with the emulator, so that's what we're connected to. The next step in our sequence or application steps will be to set up the image. If we're setting up the image for a real, machine vision type of situation, I'm going to work a lot with the triggering of the camera, the lighting, the exposure, and all of that stuff. For this particular example, we're going to load the images from a PC. And as a reminder, if you are working with an actual camera, the most important thing when working with machine vision is lighting. So the ambient light is what you want to try to either eliminate or completely control. We can eliminate ambient light by putting our vision system inside of a let's say smoked windows, plexiglass enclosure, and having LED lighting from inside. We can drown out or eliminate much of the ambient light by kind of washing it out with the lighting from the camera. Or we can be dependent upon the ambient light. And if you're dependent upon the ambient light, it'll work great as long as the ambient light never changes. Meaning if somebody walks by and casts a shadow, if you have fluorescent tubes around that start to flicker or go out, all of this would cause us trouble. So we're going to load images from a PC today, so we're not going to be concerned about ambient light. So I'm going to point at the folder where I've saved these fuse images right here, fuses. Hit OK and hit OK. And I'll see the little film strip down here will show me my fuses. If I click on one of them, I can see the individual fuses that we're going to be using. These are little spade type fuses. You might see them in automobiles, for your stereo or your turn signals or something like that. You may also see them installed in a lot of 12-volt DC devices, inverters or chargers. We even have them on some boats and things like that. Very common fuse. You see it at the automotive store. The way this fuse works is any current for this circuit is going to go into this spade lug here. It's going to flow through this filament and then out to the other spade lug. It's basically a switch. It's basically a thermal switch. And what happens is if too much current flows through this filament, the filament will heat up and it will burn out and it will look like this is what will happen. So they've sized this filament in such a particular way that a 15 amp fuse will allow 15 amps of current to flow. But you exceed that and try to run 20 amps of current through there and you'll end up with a fuse that looks like this and it will break the circuit. All right, So it's fairly easy for us to scroll through these images and tell you that that's a bad fuse, good, good, bad, good, bad, good, 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 and so on. I've had people that have tried to do this particular application in the past, and they will go into this window and scan this window and look for the number of black pixels. The thought is the number of black pixels inside this white window is fairly constant for the good fuses, right? And then the thought was, well, maybe it changes for the black fuses or for the burnt out fuses because a portion of that filament burned out. I would advise I would not advise going that route. We have the power of the folks from Cognex, these software folks that have built some tools that are going to work much better than that for this particular application. So I'm going to go to locate part first. And what we want to do is we want to tell the software where this fuse is in the region of interest. As you scroll through these images, notice what the fuse does. It goes left, it goes right, it goes up, it goes down, it maybe turns 5-6 degrees that way, 5-6 degrees that way. And so it's never in the same spot twice. In the early days of robotics, what we've done is we've fixtured parts such that we always put that part in the exact same spot. So when the robot goes to weld it, it's putting the weld in the exact same spot. Nowadays, we use vision for a lot of this type of stuff, so a robot can go find a part or go find a feature and do what it needs to do to that feature, regardless of the orientation of the part. That's kind of what we're doing with our inspection here. Is I want to tell the vision system that this is the upper left corner of the fuse, and I want to fixture that. So that way, where this window is, where the filament is always going to be there, regardless of if the fuse is up here or the fuse is down here, because it's always going to have an origin that it knows. And the way I do that is I do that with the location tools down here in my toolbox. So if you go down to the pattern, and I've got version 5.7.2 right now of the software. There are a lot of different versions of the Cognex Insight software. Our cameras actually in the lab right now, their firmware is only updated up to like equivalent to the 5.6 version of the Insight software. So I'm just going to use pattern. I'm not going to use the PatMax or the PatMax Redline, which are kind of more advanced tools that have been developed. I'm going to use the very basic tool called pattern. I'm going to double click on that. And within that pattern tool, I have two different boxes. I have an inside box here and an outer box here. And this outer box here is called my search box. So what this search box does is it says, hey, I'm expecting to look for my pattern or my fuse somewhere inside this purple box right now. And as I scroll through, I just want to make sure that the fuse never touches the edge of that purple box. And I can see like right there, it's getting close. I'm going to expand it out a little bit. And right there, it's actually touching it. I'm going to expand it out a little bit again. Right there, it's actually beyond it. So I'm going to bring that down a little bit. And now it never really gets outside that box. There was one right there that I'm concerned about. There's not much I can do about it though, because I can't expand it out any further to the right. So I'm going to call that good. I'm going to go to that first image of my fuses. And now I want to model a region that is similar on every single one of these fuses. So search box told me where I'm going to look for the pattern. The model is going to tell me what is the pattern that I'm looking for. So I'm actually going to kind of take this corner of the fuse, which kind of looks like this. I've got a left edge to it, and I've got this top edge that's nice and long, right? And I'm going to run that down, maybe all the way down to here even. And I'm going to call that my pattern. And when I hit OK, you're going to see that pattern show up down here. And now what we're hoping for is this little origin arrow up here, this little green origin arrow is kind of where everything's going to be fixtured from. Okay, so it's kind of the top edge up here is where everything, it's kind of our datum that we're going to measure everything against. I want to make sure that that datum is going to stay with the fuse no matter where I go. And it stays in roughly the same position of the fuse no matter where I go. Looks pretty good. I am a little bit worried on one of them here. Yeah, I don't know on that one. Oh, look what it did. It moved it down here. So I don't like that datum. That datum is not working out real well for me. So I'm going to go back into the pattern tool. And I'm gonna delete the pattern tool and just start over here. Not real happy with where that turned out, so I'm gonna go back into locate and we'll go to locate part and pattern. And instead of taking that region, I think I'm going to go to the left edge instead. I'm going to make it on this left edge. It looks like this left edge isn't going to cause me quite as much grief as that one maybe appeared to there. So I'm going to pattern off of this now and hit OK. You'll see we're now patterned on the left edge, and centroid is kind of on the left edge of the fuse. Now I'm going to go through all of them and make sure that that centroid, that origin, stays with all of them. That's much better. So what happened was, the original one that I tried to work with, when the fuse got way up to the top, it kind of lost the datum. It didn't have a datum. So I'm going to go off this left edge because it tends to stay a little bit better. You could also go off of this edge here, which always tends to stay towards the middle. But what you got to do is you got to try different things. And in this case, I'm trying different things by scrolling through the 8 or 9 different images of fuse that I have. In the real world, what I would do is I would actually go to a continuous trigger on my camera, and I would physically move that part around underneath the camera. And again, verify that as I did that, that datum or that origin would stay with the part, okay? And I do want to make sure that I don't go outside the pattern region here, okay? So I'll probably make this just as big as I can since it bounces around quite a bit. And I can see that that centroid stays with it. I'm really, really happy with that, okay? So the next thing I'm going to do is I'm going to inspect the part. I'll go back to the first image of the part. I know this is a good fuse, and I'm going to do a pattern measurement here as well. So let's see here. Let's see if we got the presence of a pattern, I guess is what we're going to do. So under inspect part, we'll go to the presence absence tool, and I want to see if a pattern is there. So I'm going to click on pattern, and I'll double click here. And it's going to again give me a search area, which I will model to something a little bit bigger. I'll move this into here for now. Model this search area to something maybe something kind of just a little bit bigger than that window where the filament is. So something kind of geometrically that conforms to that window there. Then I'm going to click on this model region, and I'm going to run this inside this window to encompass as much of this filament as I can without trying to let too much outside noise interfere. I know the fuse isn't going to blow here because this is big and thick. It's typically going to always blow on this thinner part of the filament. So I want to model that window as much as I can, something to the extent of like that. When I go ahead and click OK now, you're going to see that model of what a good filament looks like. You're also going to see a score for the current image that you're looking at. The current image is scoring at 99.7. I'm kind of amazed that it's not scoring at 100% because that's the one I modeled off of, but that's fine. It's 99.7% that pattern is present in this image. So that's a good, I'd call that an A. I'd call that a pass. If I go to the next image where it's blown, look at what happened to your score. Your score went all the way down to a 58%. That seems like a good thing to measure, right? 58%, well, if you were taking my test in class, 58% would be a fail, and 99% would be an A, right? Let's keep going through them here. Here's a good one, 96%, 95.7. Here's a good one, 95.2. These are all great scores, right? Here's a bad one, 59%. Here's a good one, 95%. Here's a bad one, 53%. What we can see is the good ones are always in the 90s, and the bad ones are somewhere close to 59 or 60%, right? That's great because that gives me a distinct difference between a good and a bad part. That means the software can tell the difference between a good fuse and a bad fuse. So now what we have to do is I want to try to give it a way to determine when a fuse fails. First thing I could do, I could go into my settings here, and I could set my accept threshold here. Maybe I want to set that to 75%. And if I set that to 75% and rotate through the fuses, I can see that when I get to a bad fuse, it actually turns red. The pattern is not present. When we get to a good fuse, the pattern is present, it turns green. That's one way I could do it. I guess I kind of like that way. It seems like a good enough way to do it. The other thing I could do is I could leave that at 50% or whatever it was and call it good. Then I'm going to get the pattern being present on all of them, but I can see that the score, I kind of like this because I can still see the score for even a bad part. So it's kind of nice to be able to see that. But if I do that, then it might be worthwhile to go ahead and go in and create some sort of signifying detail here, right? So I'm going to go ahead and grab another tool here, still with the inspect. What I might do in the real world is I might go to my outputs here and send a message to the PLC. If the score ever drops below 75% and say, hey, tell the robot to go pick this one off the line, or a pneumatic cylinder, blast this one off the line, or whatever it might be. In my particular case, I'm going to go to the plot tools. I'm going to go down to string, double click on that, and I'm going to have a message display when I get a good part is what I'll do here. So I'll go to the string tool and I'll bring my X over to 50 and my Y down to 100. And what that does is it positions the origin of your string. And then I'll go to the string tool itself. And I'm going to do a little bit of logic on the string tool. So under mathematics, go to logic, and I'll grab the else if statement. And I can see what this thing does here is if I mouse over it, it says, if this condition is true, if whatever I have for a condition is true, I pick value 1. If it's not true, I get value 2. So this will be real easy to do then. I can say, okay, if the pattern to score, so let me find this here. If pattern 2, so I go over here to pattern 2, if I go down to pattern to score, if it's less than 75%, I'll just say 75, comma, then I display the string pass, comma, if it's not greater than 75, then fail. In order to make sure it knows it's a string, I'm going to type in the words pass and fail in quotations and hit enter. Oh, I did that backwards. Notice what I did there. The score is currently 99%. I'm getting a fail. Doesn't seem like the right thing to display, right? So it should be if greater than 75% pass, if less than 75% fail. Now I can see a pass, fail, pass, fail, pass, fail, pass, fail, pass, fail. You can also see it on the screen, albeit my text is extremely small. So I'll go into settings for the string tool, and I'm going to make the text maybe 48. And I will go from regular to bold, and the default color, I'm going to make this green down here. So now it's a nice bright green, and I can definitely tell pass, fail. Look at that, pass, fail, pass, fail, pass, fail. And as much as I like that, one of the things I don't like is I don't like that I get green fail. So I think what I'll do is I think I'll create another one of those strings identical to that one. I'm actually going to copy this one completely, this if pattern greater than 75. And I'm going to go down to my string tool again and add another one. So I'll just got 2 of them now. Okay. You know what? I think I can even rename these things. If I go into here, I can call this one, was called string 1. I'll call this the pass string. And I'll go to this one. God, I don't even know if I like that now. You can't hardly see it. I'll call it string P. String underscore P. And then this one I'll call string underscore F. Just so I can tell the difference between what these two are going to do. What I'm basically going to do is I'm going to have one string that's going to display green pass, and the other string will display a green fail. You know, and as I look at this, I'll paste that expression in here. If pattern 2 score greater than 75, pass, else fail. And on this one, I'm going to move it across the screen a little bit. I'm going to put the X at like 400. And I can't remember what my Y was, if it was at like 100 or something like that. There we go. And if we go into our settings again, I think we did 48 for our settings. And we did bold. And this time under the default color, instead of green, I'll do red. There we go. That's looking pretty good, right? But now I'm getting a red pass fail. And if I have this tool selected, I'm getting a green pass fail. Okay, so that's a little strange. I was at 100 on both of them, I think. Yeah, I was. Okay, that, I mean, it's doing kind of what I want. But I think what I'm going to do is under the string P, the pass one, I think on this one I won't include the fail. So I'm going to, where it says fail, I'm just going to make that be blank. So I just quote, I'll put a space in there just so it's empty so I can know that it's a null character. And then under the string fail, I'll do the exact same thing, except on this one I'll get rid of the pass. I'll put a space in there and hit enter. And now if you want to run this, what you can do is go to run job. And if you go to play here, you'll see the passes will pass and the fails will fail. And it's got an obvious transition between the two. And there's a lot of things you can do. Again, I could have changed pattern 2 to actually fail that step, which then could go to the I/O and trigger something else to happen. For the purpose of doing this on the emulator, I thought this was just a little bit easier. I don't particularly like where they're falling on the fuse right now. I might want to move them up a little bit so I can always go back in. I can pause the job. I can go back into this, and I could change the Y value. So instead of being at 100, maybe I'm at 50 on that one. Maybe I'm at 25. I might not even have to be up that far. And I'll do the same thing for the Y on this one as well. It's all about making it easy to look at and for someone to see what's going on. I'll run the job again. There we go. I see the passes and I see the fails. And it's also worth noting, you know, if you wanted to ever, you can actually go down here and you can see your job status, you know, as to what's going on. I will tell you right now that they're all, you know, they all are passing because we didn't have a step that failed per se. All we're doing is we're printing to the screen that a step has failed, vice actually allowing a step to fail. But at least gives you a pretty good idea as far as what we're up to. Again, I could go back into this step right here, and if I wanted to make it so that the step failed, I could set this threshold at 75% and say, look, you're going to fail if you get to anything less than 75%. And now I'm not only getting my pass fails, but you'll also notice up here the step itself is failing. And what that step itself failing does is it actually allows me to down here see that sometimes I'm incrementing, but I'm actually keeping track of a pass rate. So I'm actually seeing this pass rate go down now because we are actually failing a step here. We're not just passing the step and just displaying a message. Now you see the outer band is also turning red. The next step again would be to send an input or excuse me, an output to a PLC to maybe take some corrective action based upon this pattern failure. But at a minimum, we've got the fuses inspected, we've got everything working, and we definitely will be able to make some decisions after this. So I hope that you'll watch some of our other machine vision videos that I have on YouTube, and that would conclude this video on using patterns in the Cognex Insight software. Thank you.